everyone. Thank you for joining my session here in Hamburg and online. My name is Michal Brygidyn. I'm a security researcher, and today I want to share my research with you. I'm also AWS ambassador, so in my research, I decided to find many different ways to hack into AWS accounts, to get your AWS accounts, and to get admin access on your AWS accounts. Quick question, who works with AWS, who uses AWS? Nice, okay. Let's start with something simple, HTML. It's really that simple to hack into AWS because we just need to view the source code and look for comments or JavaScript. It looks like that. We have an HTML file, and someone left a comment there. Hey, this is Docker config, blah, blah, blah. Remove this before production, of course, because here's a piece of our AWS profile with access key and secret key. And this was enough because these credentials belong to IAM user, which had administrator policy attached to it. So 2 steps, we are there, admin access to AWS. And it's pretty easy to find all these keys in HTML because right here, you can see that AWS access key ID, it always starts with AKIA. So if you know how to use regex, you can look for it on different websites, and you can find this easily. And what went wrong here? Sensitive data left in code. Please don't do that. There are many different ways to share comments with another team that will take your code from you and do something with it. But do not leave it in a place that will be readable by your end users. Next one, GitHub. Who uses GitHub? Who pushed credentials to GitHub? Yeah, so there are many credentials on GitHub in public repositories, and it's pretty easy to find them if you know what you're looking for. And in this scenario, it's not a simple one because you can find access and secret keys on GitHub. Most of them are already locked because AWS scans GitHub to protect your accounts, but there are some other ways to get into AWS. But first, an example, what we can find on public GitHub repositories. As you can see, login and password to Oracle database, or Office 365 credentials, or other passwords, all there. So I found a repository with a nice config file, but the values of these config variables were encrypted. So I was trying to find a way to decrypt them. And in the same repository, there was a decrypt function with encryption key hard-coded in it. And I asked them after that, why? That's the only place where we're using this. So yeah, why keep it outside? Thanks to that, I got access to login and password to Office 365 account. It was a part of a config file with SMTP configuration, and with this login and password with no MFA, I was able to log into Office 365 and, for example, open Teams because there was a Teams plan on that user. And with Teams, you can look for CEO, CTO, CXO, and then say, hi. And he will get a message from no reply at mycompany.com because usually that's the account posted on GitHub. But still no AWS there. So I was looking for another way in, and there was a SharePoint. And on this SharePoint, there were many files shared for everyone in company. And there was a PDF guide how to install Jira. And this was not a generic guide. This was step-by-step guide created by guys who deployed Jira for that company. And the last step of that guide was, and then we create admin user. Here's login and password. OK, thank you for that. Jira. we are a bit closer to our end goal to get to AWS, because there are many projects there. I focused on projects with AWS in name, and there were many AWS projects, AWS-related projects on that Jira. And there was one project with a task: hey, we need admin user on one of the accounts. Okay, and then in comment, here's access and secret key for that user. Yeah, thank you. And this was admin user, so yeah, not that easy as from HTML, but still, simple mistakes, simple misconfigurations led me from public GitHub repository to admin access to one's AWS account. And what went wrong here? First of all, again, hard-coded sensitive data. There are different ways to store your credentials. They made an effort to encrypt the values, but still there are better places to keep these values. And if you use encryption, maybe store the encryption key somewhere else and not next to the decrypt function. And there are also many public repositories where there is no value for a variable like AWS access key, AWS secret key, but then there's Git history, and Git remembers. So if you ever pushed sensitive values to a repository, it's not enough to just override them and push a newer version with some dummy value. You have to rotate the value, because I can look for it in Git history, and there are many tools that will do it for me, so I don't have to do that. Bad tool selection. First of all, public repository. This guy who used that public repository said that he's not a developer. He was from technical support, and he just wanted this tool to check if there is any new ticket on support and send email, yeah, I'm on it. And this tool was doing it for him. That's why he used public repository, because he didn't know any other tools. So that was the easiest for him. And risky credentials sharing, credentials in a PDF file shared with the whole company, not a good idea. And also, if you, for example, share login and password using same channel, like on Slack or on email, you need to be sure that the person who you think you're sharing it with will get this and then delete the message, or just divide this message into two different channels, send a login on Slack and a password as a secure node somewhere, or use one-time messaging tools like OneTime, that's a website, to share password with this person. Then he will just open the link and get that value, and anyone opening the link again will see nothing. Lack of security awareness. So the first one, too many viewers, credentials shared in a place accessible by anyone in a company, not a good idea. Then storing valid credentials in documentation, also a bit weird, but they said that they were told to document every single step. These were just junior admins. Every single step should be documented. So this was one of the steps, so they documented it. And do not use your own accounts in scripts. There are service accounts for your tools. You can ask admins to create one for you if you cannot do this yourself. I had access to maybe even hundreds of Office 365 accounts of real users, not service accounts, but real users, because they decided to push their password to public GitHub repository. Next one, Symphony Profiler. This is a PHP framework, and this one is interesting because it has a tool called Profiler. This Symphony has a tool called Profiler to help you develop applications. It shows you a configuration of a server. It shows you server parameters, environment variables, but also it stores the history of all requests, including, for example, post requests from login page with your plain text login and password. But with this profiler, you can also preview parameters YAML file with more configuration variables. With this profiler, as you can see, even in environment variables, you can find AWS access and secret keys or other passwords. And I found a first pair here, but this only gave me access to S3, so file storage. I don't want that. I want to be admin on that account, so let's dig deeper. Then in request history, the second screenshot, I found a request to log in to that app on non-production version. This was a development version of it. And using that, I logged in, and these were admin credentials, so I had access to dev environment for that app. But hey, this app is like dev.mycompany.com. Let's remove dev and try the same credentials for mycompany.com. It worked. Same credentials for production environment. Thank you. And when I logged in, I saw a dashboard with many apps on it. And then I realized that this is some kind of single sign-on. So I was able to open a CRM or other tools with company data, but still no AWS. So then I found webmail. And on this webmail, I found a lot of AWS invoices and trusted advisor emails. So this was the first indicator that there is AWS there. So I decided to use that email to reset password for a root user using that email. And it worked. There was no multi-factor authentication on that user. And when I asked for a password reset link, I received it on that webmail. So I got access to this root account, root user for that account, and the root user is like a god for that account, so I can do anything there. But this was not access to just one account. This was the master of the whole AWS organization, so it was like 20 or 30 accounts from getting just this one. And thanks to that, I got admin access to all of these accounts, starting from development version of random application. And here, first, what went wrong? Production data on non-production environment. If these credentials were invalid for production, it wouldn't be possible to go there and to extract everything else. So please don't do a full database copy from prod to dev. I know that customers ask to do that because this particular error only appears on production, but there are many other ways to simulate that and to do it better way. And also, not in this case, but there are many cases that companies decide to use only one cloud account, only one subscription, one account on AWS, and then keep everything there. Okay, they may say that it's easier for them to manage it, but then if I get access to dev environment and I extract some credentials from dev environment, I can talk to the same account, to API of the same account that production resources are deployed on, so not a good idea. And critical services using the same shared email. That webmail and that user on that webmail was not only used to create AWS account, but also other accounts like GitHub organization or Datadog or something else. So all in one, because we just use this account to sign up for everything. And thanks to that, I got access to everything that company ever created using that email. And then they shared this account user and password with other team members because, hey, we need team members to be able to log into that particular account because only that account holds a history of everything we've done with all these third-party services. And in case someone is on vacation, others may need to log into that. But still, there are better ways to do that. You don't need to hard-code these credentials or share them with more than one person, because then, hey, how do you know who did that? How do you know who made that mistake? And if the account is shared, usually the password is not rotated at all because no one is responsible for that. We just use that password for the last 5 years. Yeah. And no MFA. That's the biggest problem here. If there is no MFA, login and password is enough to get in. So please remember this one thing, use MFA wherever possible, but not only the one in your Microsoft Authenticator or Google Authenticator. Use YubiKeys if you have them, or other physical devices as another factor in your authentication process. And now, who uses Kubernetes? OK. This one is my research from pandemic. I decided to look for many different publicly available, accessible Kubernetes clusters that are out there. And I used Shodan, Census, and Binary Edge. These are evil search engines that scan the whole internet, all IPs, all ports on these IPs. And they index all banners, all responses from these ports and these IPs. Thanks to that, I can look for Kubernetes API that's publicly accessible. I'm not Kubernetes expert, so forgive me if I'm using other names that you're using, but for me, it's just API there, and I know how to find it. And when I do, I have access to secrets, config maps, and a list of pods, for example. And all these using just my web browser, so no special tools. These are misconfigured public endpoints. So if I need a config map, hey, API v1 config maps or something like that, and I get whatever I need. A list of pods. Nice, I can see that there is Jenkins, for example, that I can use. A list of secrets. Yeah, just decode base 64, and you will get plain text credentials directly in your web browser without providing any password, any key, any certificate, anything. It's just anonymous access there. And that's how I found many, many AWS credentials in secrets, for example. But not always it was that easy that these credentials gave me admin access. So in this scenario, we are digging a bit deeper. First keeper that was S3 access only. So then I found Jenkins credentials in one of the config maps. And Jenkins was also one of the pods running there. So I configure my kubectl to connect to that API and to forward ports from that Jenkins to my local machine. And then I was able to open that on my machine, that Jenkins app, and using credentials from config map, I was able to log into that Jenkins. And if you use Jenkins, you know that when it builds something, it creates a workspace with the source code that it works on. So you have access to the source code if you're there and if you're admin. You can check if there are any sensitive information in the source code itself. Or you can look in different places like console log from different builds or Jenkins credentials. Because Jenkins credentials are not, it's not a secure way to store your credentials, because if you're admin, you can just extract them in plain text. And I found in the console log, I found that one of the jobs was using AWS CLI to communicate with AWS. And I was also able to either use Jenkins scripts window or to exec into that pod with bash. I was able to use the same and to just communicate using AWS CLI, and it was a role attached to that node that allowed me to be admin on this AWS account. That easy. So yesterday we heard on a different talk how to get access to Azure from Kubernetes, but I'm doing this for AWS. So yeah, it's still easy, and still many, many public clusters out there. I don't have numbers right now, but when I run my script every month, it was like 300 new IPs every month. So yeah. What went wrong here? Lack of knowledge. If a resource is deployed in a public subnet with public IP and no other security things on it, then anyone can access that resource. And also, when I asked the different companies why it's there and why you didn't find it, oh, it's non-prod, and we don't have pen tests for non-prod because it's cheaper. Yeah, why not? Or risky design. We want this to be public, but hey, it's random IP. Only we know that IP. You shouldn't know that IP. We just left it open because we have teams all around the world. We don't have VPN, and they have dynamic IPs. So either we whitelist half of London, or we just open it and leave it open. Disable security features, role-based access control disabled, anything else there available, disabled. So if you know the IP, you have access to everything. I don't know why, but many instances of clusters with no security at all is still there, and people still work with these clusters. And also, there is a problem with encrypting data. Many times I would not be able to extract anything sensitive if the data was encrypted. But hey, you need to spend time to make this logic to encrypt it, to decrypt it, to store the encryption key somewhere safe. So yeah, please use encryption wherever possible, because then it's harder for me to get your data. And yeah, as I said, no firewall, because home office dynamic IP. We don't want to make this harder for our developers, and we don't have money for VPN. So yeah. And second thing to remember: principle of least privilege. If someone joins your team, do not give him admin access to everything. If he needs to work with one S3 bucket, give him access to one S3 bucket. If he only needs to read information from one cluster, give him read-only access to one cluster. That's all. Because then if he loses his keys somewhere and I find them, I will not be able to do what I did here. I will just have access to something that I don't even know what, because my script only checks the most important things, like listing users, getting a root email from support API, or getting the spend from last month. So if my script gets 403 from this, it will ignore all other actions. And very interesting one, unprotected CI/CD tools. You know, it's not only how you protect your cloud, but if you have your cloud and then you have your pipeline that deploys resources to your cloud, and the pipeline is secure, your developers don't have access to a production environment of your cloud, but your CI/CD tool has full admin access to that prod because it deploys things there, and your developers are admins on that CI/CD tool, then hey, they can do whatever they want on that CI/CD tool to create, for example, a malicious job to deploy whatever they want on cloud environment that they don't have direct access to. Or if they are not admins on Jenkins or other CI/CD tools, but they can push code directly to a branch that is used as a source for CI/CD. They can push whatever they want if there is no manual step of merging this, or yeah, they can just directly push to master. Then it will trigger CI/CD and it will deploy things to your cloud. For example, EC2 with public IP with admin access, so I can log in and get your account. And running apps as root, also not a good idea because but you know that if you run app as root and I get access to this app, I have access to your, for example, host, and I can do whatever I want with that host. And recently, like 2 months ago, there was a 0-day at Confluence, I guess. And with that 0-day, it was possible to run any command on all Atlassian versions for the last 18 years. So from 1.3, I guess. I don't know, it's 8 point something now, but it was possible to run any command. For example, for me, it was a command to extract metadata and to get temporary credentials to your cloud accounts, but others did other things like getting access to host and then jumping to other resources in the network, getting a full domain controller admin or something like that. And there are more scenarios. I still have some time. So, for example, outdated software running on cloud servers. Yeah, also Atlassian as example here. There is a bug that was discovered in 2017 in many Atlassian products, Jira, Confluence, Bitbucket, that there's open proxy, and you can use that as anonymous user on the login page. With write the URL, you can ask for any website to render there. So I asked for metadata, this IP of metadata, and I got temporary credentials used by Jira instance on AWS. And yeah, this was admin access because I didn't know how to configure it properly. This is version 7.3.3, so pretty old, but there are still many, many old versions around. And admin credentials logged during the installation. For one of the customers, I checked his AWS accounts, and I found logs in CloudWatch from the installation of Jenkins. And at the end of this log, it was login and password to super admin user on Jenkins, and Jenkins was admin for his account. Then misconfigured vhosts with the directory indexing. If you have your vhost configured to point to direction A, but then default vhost points to direction 1 above A, then you don't have any index files, etc. in that location. So if you go directly to IP, you will go there and you can see what's there, maybe some interesting files like .env files or other config YAMLs. It looks like here, like this one. Then we have debug pages and connection strings. My example, Python Django. If you use Python Django, you know that on debug pages, it uses these stars to hide all sensitive data like keys or passwords. But then you have Celery broker URL. This is not a password, not a key, but it consists of access and secret key for IAM user on AWS. And that's all. Thank you.
Cool, thanks, Michal. Who's off to check their repo now for sensitive data? Who recognized their own repo? There. Yeah, interesting. I feel a bit dirty, to be honest. I'm like, a fair few questions. So even if you find some exposed Kube APIs, how would you figure out the credentials?
Funny thing, I don't have to, because all these APIs that I find don't have any authentication on it. It's just anonymous access, so I just grab and use it. Yes, it's really the case. You can find it yourself. It's there.
Well, there you go. Hacker at the making. Would you mind sharing the Kubernetes API discovery script?
You know how a Kubernetes API page looks like. Just grab a string from that page, open any of search engines that I mentioned, send this binary edge showdown, put the string there, and wait for a response. That easy.
Cool. All right.
But don't do that. Or wear your white hat.
So what is your opinion on running runtime security scanners as privileged containers?
I don't have opinion on that. If there is security scanning somewhere, it probably knows that there is a vulnerability, and you fix it before I get there. So I don't like them.
Making your job difficult.
Yep.
Cool. What was the website for the one-time password link to send out?
1ty.me. One time. That's the site. But if you use that, please put only password there, not login and password. If you put only password, then for the website owners, it's just a random string that they share with someone else. But if you put login and password, this may lead to something.
Yeah, you're still sharing your stuff with somebody else.
Yep.
You don't know if you can trust for that. Cool. which ways one would simulate production and development without copying everything?
You know the amount of data you have in your production database. You know how this data looks like, what type of data you have. So you can try to create an anonymous database with the same amount of data in it, but it's just lorem ipsum data.
Yep. Have you ever attempted to scan for public domains that could potentially be reverse proxies for the Kube API sitting in private networks?
So what I do, I just ask for IPs. I don't look for domains. I ask for IPs because these search engines give me IPs, and I don't need to know what domain is in front of it because there's so many records when I ask for just IP. Then I don't need to look deeper. I get more records than time to process them.
I like how it got upvoted immediately. Could you share your credentials with us?
Yeah.
You'll probably change them fairly quickly. So.
And they will not be mine.
Fair enough. What's the biggest company you found vulnerable at? And if you want to keep the company anonymous?
Okay. The biggest in terms of users in Active Directory, it was 300,000 users because this was an university somewhere in Brazil, and all users. Well, I just got access to Active Directory, Azure Active Directory there, so access to all details for all users there. That was the biggest one.
Commercial company, not a university?
Commercial company. There was one, and thanks to them, I now drive Volvo XC60, but I cannot mention the name.
There you go. So open up your credentials so he can upgrade his car. Yeah, there you go. I would love to have all your scripts. Would you mind sharing them?
These are easy scripts, so if you know what you work with, you can do these scripts yourself. I just use a bit of Bash and a bit of Python. It's very important to know what you work with, and I started with PHP, so I knew how to work with PHP. Then I moved to Python, I knew how to work with Python. Then someone forced me to use containers, then I knew how to use containers. And thanks to that, I knew what to look for, because as a lazy developer, I was looking for the shortest path. And thanks to that, I knew what security things I was omitting. And then now I know what to look for, what developers are not doing, because it's easier not to do that.
Cool. So you don't have a public repo we can take stuff and check for credentials.
I thought about it. So yeah, maybe one day. But until it's that many records, I will not do that because I don't like chaos. Sorry.
Fair enough. And the last one's just a hack, I think. Somebody's trying to hack Slido.
This is the end? Yeah. Okay, thank you.
Cool. Thanks, Michal. Really interesting talk.